let us see what is the electric current. We know that the flow of charges that causes the current, and that is called as the electric current. But before the discovery of electrons, the time when electrons were not discovered, that time it was considered that the positive charges are carried from positive body to the negatively charged body. Then the body with the positive charges, that is deficit of electrons, that was considered as at the high potential, and the body with negative charges, that was considered at the low potential. Like if we observe a waterfall, the water falls from higher level to the lower level of the waterfall. And if we consider that example of a waterfall, we can say that the water flows from higher level to the region of lower level, and this flowing water has a particular direction. The same way, the charges were flowing from the region of higher charges of the higher potential to the region of lower potential. So this was considered when the positive charges are carried from high potential to the low potential, and potential is the ability to perform the work. Like suppose now there is lockdown, so you are indoors and your activities are reduced and you are spending time lazily. We can say that you are at the low potential. But if you go out for a picnic, then your activities increase and suddenly your potential is higher. So that is the high and the low potential. Then after the electrons were discovered, after discovery of the electrons, then it was evident that the electrons are flowing from negatively charged body to the positively charged body. That was against this, because here what was considered? The charges are flowing from high potential to low potential. But in fact, it is flowing from low potential, from negatively charged body to the positively charged body. And so then the direction of current, that is from negative to the positive. When this was discovered, without disturbing that concept and to avoid the confusion, then the direction of this conventional current, it was considered opposite to this. And then we know that the direction of current is that from negative terminal to the positive terminal, that is from the low potential to higher potential. Electrons, they flow from low potential to high potential. Like if you consider example of the clouds, clouds have the negative potential, negative charges. So this is the negatively charged body, and the lightning strikes the ground, lightning strikes the earth, which is at the zero potential, that is more potential. Zero is greater than negative. And so this is the flow of the electric current from negative to positive terminal or the positively charged body.
Start.
Now the potential difference, that is the difference in the potentials at 2 points, that is called as the potential difference. And how it is calculated? It is given by the work done to carry the charges, positive charges, is the potential difference. Suppose this is the electric field. This is a negatively charged plate. This is a positively charged plate. And one positive charge is placed in the electric field. Now to carry this positive charge to the positive plate, from negative to the positive plate, some work has to be done. And work is done to carry it here. When the charge reaches here, the same charges will have repulsion. And so if we do not do any work, then what will happen? It may come back, it may fall back, because there is attraction between these unlike charges. So to hold this positive charge towards the positive plate, we need to do a certain amount of work, and that work done to carry the positive charge, that is the potential difference. So if 1 joule of work is done to carry 1 positive charge, 1 coulomb of charge, then that is called as the 1 volt of potential difference. And if we use this formula, it will be given as V is the potential difference and the work done upon the charges which are transferred. Here V is potential difference, W is the amount of work done, and Q is the charges which are transferred. And the SI unit for potential difference is volt. So 1 volt is given as 1 joule per 1 coulomb. 1 volt is equal to 1 joule per coulomb. You call it as potential difference or voltage or the potential energy difference. All these three are the same. Commonly we call it as voltage.